So, little build-up. I had started doing internet back in the 80s when the DNS protocol specs were being done. And at that time, it was a very different environment than the internet these days. We literally did know the other site. So if something malicious was happening, you could usually do a finger on their machine, find out who was logged in, you knew what phone number to call, and it was usually the, oh, it's September, the new student interns are in, as opposed to something malicious. So that was the environment in which most of the DNS protocols were developed. Unfortunately, it has proven to be way more resilient than any of us expected and far more useful. And so these days, it's pretty much critical infrastructure. And so the abuses have started to really go through. So I'll start talking about various types of servers and what's happening to them, and then get also into where the protocol itself is being abused. So the first thing that really started happening was attacking the cache. And I'm not going to go into all the details of how resolution works for this crowd, but the key takeaways are essentially caching is useful because if you get at least an 80% cache hit, it really helps your server survive the experience. And the other critical piece, of course, is that you take those records and you cache them based on what someone else gives you, including both the data and the time to live, i.e. how long you keep it before you check with the authoritative servers again. So cache poisoning started becoming a problem back really about 8-10 years ago, noticeably. And more or less what it is tricking your cache into putting something that isn't true and that isn't what the zone owner wanted into your cache and then starting to serve it to your customers. And there are a number of reasons why that worked. Some of them that do get down to the fact that the DNS protocols themselves really weren't designed with security and authentication in mind. They were simply a, I need an answer, here's your answer, walk away. And some of them were flaws in some of the core implementations themselves that we simply hadn't noticed. Some of them were things, including message IDs, that I'll talk a little bit more about. One of the other things that's starting to be a problem with this is there are also, as I'll talk about more when we get into the DDoS section, open resolvers. So you can additionally poison some of those folks by being able to ask certain leading questions and making it much easier to corrupt that data. So if you do get somebody's cache poisoned, effectively you've got a man in the middle. You can get them to a completely different machine than the zone owner intended. You can get them to a different web server and steal login credentials or do drive-bys and dump malware onto their machines. You can send email to the wrong places. You can have file transfers and VPNs going places they aren't really expected to go. The earliest one was cache-prof, which it had a couple of things that you had to do. One of them was you had to have your own name server that broke the protocol and lied. And you had somebody who was asking evil leading questions. So in this case, the internet, which was in those days pretty much the registrar, was rather important. And there were folks that were trying to get you to come to alternative routes and alternative registrars. And there's an interesting problem with glue. Glue records are, as we know, if I want to have the IP address for the name servers for Google, and Google chooses to have them within their zone, ns.google.com or ns1, ns2.google.com, if I go to the com servers, it will happily say, you should go to ns.google.com, at which point I need to go to the google.com name servers to get the IP address of the google.com name servers, which is an unsolvable problem. So what we did was we have additional records, one type of which is glue. So the TLD, the com server, gives you actual A records for stuff that's outside of the com zone as a hint. It gives you the NS records that it's supposed to as a delegation, but it also gives you those additional records. And in the old days, we did not look at what was in that glue and whether we should really be necessarily getting that information. We just took the glue and happily stuck it in our cache like we got the actual authoritative answers. So what would happen is the evil resolver would ask for a question, get back the question it asked, but they would also give glue with an additional A record completely unrelated to that zone. Next thing you know, that cache is poisoned. Another problem was that message IDs, it really is nothing more than like a luggage check tag. Here's the bag you gave me back. And the only authentication you have is that the answer comes back with the same message ID that you asked. There is no authentication of who gave it. Anybody who has that number, anybody who has my bag check can wander off. If I lose my bag check in the tube, they can go to my hotel and they've got my bag. So unfortunately, it really wasn't designed for security. And the random quality of it was simply so that you had enough of them. So the problem was that they discovered that there were some flaws in bind where the random number generator they were using wasn't at all random. Nice scary one. If it was an even number, you were down to 10 possible values out of the 16 bits, which obviously was not terribly sufficient. And all you had to do was iterate quickly, and you had the string, and then forever thereafter you were correctly guessing. What that meant was that it became trivial for you to know that message ID that you were supposed to send. So even that form of authentication pretty much became useless. There's a page of math here for those of you who are interested. It's in the slides. I flunked my basic stats class, so I will forego this. But the basic premise is there's something called a birthday attack, which basically says, what are the odds that for any number of people in the room that two of them will have the same birthday? And most of us would come up with if there are 300 people in the room, then the number is 1 in 300 or 2 in 300, and we would be horribly wrong, and you would flunk stats like I did. The reality is that, as you can see, it takes very few people in the room before you get to a pretty damn good chance. In this room, we are already basically into, there's pretty much 2 people in this room that have the same birthday. It's a given. Similarly, because of all of that really spectacular math, the odds of you being able to get a message ID correctly, not 64,000 possible answers, but effectively by the time you sent 600 packets, you pretty much knew that your message, one of your packets was going to match. So Dan Kaminsky looked at this and did some other things and realized that this meant that you could guess a message ID for a DNS query trivially. It was no longer thousands of possible random numbers. It was a few hundred, which takes no time to send out. So what you do is you simply send out a query with a random string dot whatever the domain name is. Random string because that means you know it hasn't been cached, which means that you know that that recursive name server is going to go off to the authoritative name server for PayPal. This means that in that period of time before PayPal's server sends that NX domain back, you have a chance to send this flood of 500 or 600 packets. And timing-wise, all you have to do is have a really fast link and do this 8 or 10 or 15 times, new random string every time, and you suddenly have the right message ID, and they take your answer instead of what PayPal gives. And you get to put in glue or override the DNS record or whatever you want, and suddenly that recursive server is cache poisoned. And that was the thing that sort of kicked everybody over, because suddenly it wasn't it's 10 hours, it's 15 hours, it's 20 hours of crunching. You have to be in exactly the right place. Pretty much any PC in the world had a pretty good chance of corrupting your cache in no time at all. So there was a feverish rush with all of the major name servers because everybody was vulnerable, because it's a flaw in the DNS protocol itself. And there was this whole cabal of people that for about 9 months secretly worked feverishly to try and figure out what they could do. Well, one of the things they could do was they tried to make things more random. And this is like firewall in the building code sense of the word firewall. A firewall is not a fireproof wall. A firewall is a wall that has been rated to burn for some amount of time before it is consumed, giving you the chance to hopefully either put the fire out or smell the smoke and run. It is not designed to prevent, it is simply a stopgap. Increasing the entropy of the message IDs and source ports by which we query, because it used to be everybody sent queries from port 53. So you now knew the port number, you could guess the message ID number, and so any vestige of security we had for who asked was gone. So randomizing source ports and fixing the random number generated for the message IDs and doing a few other things increases the time. But it got it back to hours from minutes, not really fixing it. So what do we do with our cache? Well, obviously, we did the code that we could and got much more strict about glue. We actually looked at things like, is it PayPal's server that gave me glue with PayPal tokens in it before I stick it in cache? Once I get something that I'm about to stick in my cache as glue, maybe I should actually go to the authoritative server and see if it matches before I stick it in. If I get glue records from Com, gee, it's really nice that I got those glue records, and now that I've got to the DNS servers, if I ask him who the DNS servers are, I should probably be more inclined to believe him as to what the A records are, so I'll overwrite glue with authoritative answers. So we tried to improve the quality of what we kept, but the reality is that the best we could do on data is DNSSEC, and that was really the thing that suddenly got DNSSEC back onto the radar as something we should be doing. And I won't dive into all of the painful details of what DNSSEC does in terms of validation every step along the way, but essentially what it meant was if you're willing to make one single leap of trust, start with the trust anchor, i.e. that the public key that is used to sign the root zone is distributed in a way that we believe is safe, and they have the whole key signing and key rollover ceremonies, and it's webcast, and we have guys with little cards, and this very elaborate little ceremony now. If we're willing to make that leap of trust, then step by step we can cryptographically validate each one of those DNS labels all the way through the chain down to the record we're looking at. And what it gets us is that I, as the validating resolver, if I am doing DNSSEC validation as a recursive resolver, I can be confident that the data that I got was from the authoritative server and has not been altered in transit. That's all it gives you. Now, if I put crap into my zone, or one of my provisioning people puts the wrong IP address into my zone and I sign it, it doesn't mean the data is correct. It simply means that's what I put in the zone. So, but it's at least a piece, and that's a pretty important piece. So that's mostly the thing that we see with recursive resolvers, other than just sheer raw bandwidth overwhelming. And to be honest, in most cases, the pipes that we're sitting behind are far more likely to melt than we will be able to overwhelm a server with too many queries. So the other half of this equation are the authoritative servers. Okay, so what can we do to the authoritative servers? Well, again, for the most part, it's just sheer fire hose. What has become alarming over the last several years is the size of that hose. There are literally tens of thousands of bots these days running around loose, possibly hundreds of thousands, but most security experts are pretty comfortable. There are literally tens of thousands of active, talking to their command and control system, waiting to abuse you bots, waiting for someone with a check and a bad attitude. There are literally tens of millions of open resolvers that they can use to ask queries of, to send data out and either overwhelm your pipe or overwhelm your machine. The OpenResolverProject.org currently still lists 27 million hosts that are open resolvers. And the reality is that even if we could get everybody that ran a legitimate name server with a real operating system to upgrade their code and put on ACLs and do all the rest of it, probably half of those are crusty little CPE boxes that have some ancient version of DNS mask or something similar that answers on the WAN side as an open recursive resolver. And raise your hand if you don't have Windows XP boxes somewhere buried in your enterprise, or users who have gear that's over 4 years old as a CPE. Yes. And I can say the same because I'm the ISP for my home. But my CPE was only replaced recently when the power supply blew. It was 6 years old. So I'm no better than anybody else. So the reality is the tail of getting that other half is unfortunately probably years away. And you can generate gigabits of traffic in these attacks now. We are seeing tens of gigabits. We are pushing into hundreds of gigabits. And the reality is if I can shovel 100 gigabits of traffic towards you, if you are a major IX, you will notice. You won't go down, but you will be wondering what the hell just happened. And if you aren't an IX, you're done. Your link is gone. And the number of attacks and the persistence, pretty much anybody who has a public network is being attacked regularly. These are kind of scary numbers. The one that blew me away was I talked to someone who owned one of the root servers. And I was saying, well, if we're at, most people are experiencing hundreds of DDoSs a month. How many do you have? And he said, it doesn't stop. We are under continual attack every minute of every day of the year, and we over-provision based on the assumption that we will always be dealing with these floods of packets. And part of the reason is 10,000 bots doesn't sound like much until you start doing some math. And one of them is that even if it's a really crusty little PC, it can do hundreds of DNS queries per second. And it can forge packets and UDP queries or DNS queries or UDP. So I can forge the source address. And I can send out a 40 or 60 or 80 byte packet. And if I'm asking for the DNS records of somebody who's doing DNSSEC signing, I can get a 4K response for an 80K packet. Trivially. And for bonus rounds, if you're using NSEC 3, where you have DNSSEC proof of non-existence, where instead of having NSEC where you can walk the whole zone because you have records that bracket around. So if I ask for foo.example.com, what will happen is I will get a signed record with NSEC that says I have charlie.example.com and golf.example.com. Foo would have been between them. Nothing's there, and I've signed both of those bracketing records so you know authoritatively that I don't have the record you asked about. Well, NSEC 3, they didn't want to show that for a lot of the TLDs, so it generates hashes on both sides of the value you give it, which means that your authoritative server is doing prime number math twice for every non-existent zone label. So if you'd like to DDoS yourself, just do NSEC 3 signing. If you don't have to do NSEC, don't do it. DNSSEC is useful, NSEC a lot less so. So you've got these really high yield results for very little effort. So suddenly we have tens of thousands of bots doing hundreds of packets a second, very small, generating thousands of bytes of response, and suddenly you get the math and you go, oh, well, that's how you get to 10 gigabytes. Okay. So some other things to keep in mind as well. New York Times and Twitter and Huffington Post had fun last week because someone did a spear phishing attack on the Melbourne registrar, got some credentials, and got access to registrar accounts and changed the NS records for their zones and picked their own. So while you're sitting there thinking about getting enough bandwidth for your machines and all the rest of it, consider the possibility that you don't get to say what the zone data is because they've stolen the NS records away from you. And think about your name server TTLs. There are advantages and disadvantages both to having long and short TTLs. So, again, what do we do to actually defend? Well, one of the key things is it'd be nice to be able to do perimeter ACLs on your authoritative zones, but in reality, we mostly can't. If I'm a recursive server, I know who is going to be asking me the questions. It's my customers or my network or my company, but I don't know what questions they'll ask. They could ask for any zone on the internet. Authoritatives have exactly the same, exact opposite problem. I know exactly what questions I will be asked, because they will be asking me about the zones I'm authoritative for. However, I have to answer anyone on the internet. So unless it's something like an internally visible zone in views, you usually can't do ACLs. For the most part, people will throw high-capacity servers. You know, my company loves selling these big honkin' boxes to people who want to beef up. Throw money at it. You can do clusters or load balancing, but they're a lot less effective for DNS, particularly for authoritative. Because usually if you're getting that kind of flood, what you're fighting is that your bandwidth uplink is clogged, not that your server's capacity is being strained. One of the more interesting ones out there, though it's more interesting in terms of you being a good citizen to others, response rate limiting. There are patches for all of the major implementations and commercial products out there. There was a very good, another pitch for OARC, there was a very good paper in Dublin that Dave Knight did showing how tuning various values for RRL gave you various payback. We're still wondering exactly what's going to be best because we haven't even decided exactly what filtering we're using or what knobs to put on RRL yet. If you have input, please get back to me, get back to ISC, get back to other folks who are doing these implementations to tell us what's useful to you. You can also do fatter internet pipes to survive, and that indeed does help. But if you beef up your servers and you beef up your internet pipe, you become a much more interesting hammer to use to clobber someone else. You can put in authoritative servers, more authoritative servers in for your zone, but only to a limited number. You know, we should always have 2, but realistically, when you get much above 5 or 6 authoritative name servers, it becomes less useful. Different OSs do less useful things with it. And once you get over 512 bytes for the response packet, suddenly you have problems with people who are filtering eDNS 0 and doing other suboptimal DNS proxying, as so many boxes seem to do. You are breaking. The most interesting thing you can do in many respects, other than just fatten up where you are, is to anycast. The reason that botnets are so dangerous is they are splattered across dozens of ASs all over the world and hundreds of address ranges, so you trying to do ACLs to lock down one PC is just playing whack-a-mole. But by the same token, if you anycast your servers, you have diluted how many of those botnets can attack that one server in that AS that's announcing that anycasted server. So you are effectively using some of the means that they are using to attack you to defend yourself. HA is another, I class it more like load balancers. It's certainly good to have high availability in your servers, but again, bandwidth is probably where you're going to die. Here's my sort of commercial public service announcement. We all worry about DDoS and how do we defend ourselves. But the reality is that most of what's happening is we are being used to abuse others. And the appeal I would make is that someday it's going to be you. And you will probably appreciate it if everybody else around you was a better internet citizen. If you're letting spoof packets out of your network, you're part of the problem. And there was a mentioning of asymmetric routing. Yes, BCP38 does not handle gracefully multi-provider, which is why BCP84 has been around for 7 or 8 years. Read that RFC 5358, which is DNS amplification and how not to be a DNS amplifier as much as possible. If everyone in this room and all of our customers were doing ingress filtering and we were doing response rate limiting and some things I'll talk about in the last section, we would have a much less effective set of tools for these guys with botnets. Now, it just means they'd find something else, but it would take them a while to build up to something else nearly as effective. So, the fun part, DNS abuse. So, DNS is there to be a loosely coherent distributed database. It is there to answer what is the corresponding data that responds to this label, and it might be addresses or whatever. People are finding very creative ways to use it. They're tunneling with it. Kind of cool to see TCP over DNS, I suppose. The huge one is command and control. You know, all of us have probably railed for years about apps programmers who hard-code IP addresses, who use partially qualified domain names, all the rest of it. These guys are using DNS. They're shuffling through those records fast. They're doing all of the things that we've been telling our coders to do for years. Storm and Configure and all of the modern botnets out there are doing this. They are using DNS. So when you wake up, you make a DNS query, and it says, oh, here's the latest version of code. Please do the update. And by the way, be ready for commands, including DNS amplification. And we like to protect our users, but traditional things have problems. Antivirus. Yes, it's useful because there are people who still have 7-year-old viruses that are effective because they haven't patched. But the reality is it's just due diligence. There are too many mutations happening all the time. Literally, they're happening every 5 minutes all over. And it's very easy to disable antivirus. Perimeter defenses are also a good thing, but in most cases, they can't catch a user who comes in infected. You know, if my kid downloads a screensaver that includes malware onto my iPad or my laptop and then brings it to work, your perimeter defense doesn't catch that. Most of the updates are from that vendor only or from your own company. There is no public source of information to update necessarily. So one of the things we started to do was use DNS as a defense. Got reputation feeds just like we get spam feeds. You can do it based on DNS label or IP address. It uses all of the things that we love at AXFR and IXFR for effective transfers. It uses Notify, so it's fast. You can get multiple feeds, so you can share that data with other people. And as soon as the client wakes up and makes that first command and control, you can catch that because you are their recursive resolver. You can immediately decide whether you want to let it through. What do you want to do? So all of these things are useful. Perimeter devices, antivirus, RPZ, RRL. The key is layered approach. Use all of them and do as much as you can to protect others as well as yourself. Questions?
Ilya Voroskin, Easy Night. Not to question, but actually to add something to your presentation. Don't forget about /32 and /128, because if your service depends not only on correct DNS records, but also on the presence of records or on the presence of answers as such, if some malicious guy starts announcing your /32s, you're screwed.
Yes.
So it's just a call to people that look not only at DNSSEC, look also at securing your BGP stuff.
Oh yes, I would certainly put in a pitch for our PKI. BGP is another festering hole that we have tried to ignore for years.
Any other questions for Paul? Okay, thank you very much, Paul.
Thank you very much.